Welcome, welcome everyone. I see everyone's filing in for tonight's presentation. Welcome to GIS After Dark. This is the February edition, so it's nice to see you again. Thank you all for joining. I'm going to wait just a minute before we get going, but it's so nice to see so many attendees and so many students that I recognize. So thank you guys for being here on a beautiful Thursday. All right, well, let's get started. So again, welcome to GIS After Dark. And many of you, if this is your first time attending, or maybe you've been attending for the last year, this series is hosted by Johns Hopkins University, AAP, Geographic Information Systems Programs. And for those of you that are joining for your first time tonight, I am the host of the speaker series. My name is Dr. Cassandra Hansen, and I'm the program coordinator for the Environmental Sciences and Policy and GIS program at Johns Hopkins. So we designed this series to really highlight the amazing work that folks are doing within the GIS industry. And so I try to bring in the best, the brightest presenters, and I'm so pleased and excited for tonight's presenter. We get to hear from Lotem Taylor from the National Audubon Society. But before we get started, I like to get an idea of who we have with us this evening. So I'm going to go ahead and launch two polls. The first one is going to ask about who you are. So are you an alumni joining us tonight? Are you faculty? Are you a student? Perhaps you're a GIS professional. So go ahead and put in your answers, and that's going to be the first one. And we'll give you a couple seconds there. And then the second poll, so after you finish the first one, is really just to get an idea of your background. Perhaps you are in the industry, you're using GIS, or perhaps you are you're hearing about it for the first time. So poll results are just in. Looks like we have 52% AAP students, so welcome. We have faculty joining us tonight. Welcome, welcome. GIS professionals and 28% general public, so thank you. And the second poll, I just want to get an idea of your background. Have you heard of GIS before? Are you a working professional? Are you interested in GIS? Perhaps you're new to the field. So if you could just take a moment and let us know where you're coming from, that would be fabulous. Okay, so get those answers in, and we'll look at the polls really fast. Okay, so we have 15% that are GIS professionals, 31% GIS students. Interested in GIS? Absolutely, 27%, and then 27 new to the field. So welcome everyone. So this, like I said, this seminar series is to really have that discussion about GIS and talk about how GIS is used in the industry. And so if you have any questions throughout the presentation or throughout the hour, feel free to put your question in the question and answer, or put your question in the chat box. And at the end of the presentation, I'm more than happy to give voice to your questions. Or if you raise your hand, you can actually ask your question yourself. So before we get started, I keep on saying before we get started, where are folks joining from tonight? So if you could go ahead, open up that chat window and let us know where you're coming from tonight. I know this is a global program, so we have folks from around the world. So we have Seattle, Washington chiming in. So it's not quite after dark yet. San Diego, excellent, Oklahoma, Chicago, so welcome. So this is definitely a collective group from all around the country, all around the world. Welcome, welcome, welcome. So nice to see so many returning folks. Okay, so as we know, for many of you, who are new to GIS, for those of you who are returning or use GIS on a day-to-day basis, we know that GIS stands for Geographic Information Systems, and it is a tool that helps us collect data, helps us to analyze the data. It helps us create maps and visualizations and apps to help communicate complex patterns over space. And so we've seen, in the last 2 years now, almost going on 3 years, we've seen GIS at its maximum capacity, communicating the spread of the coronavirus in the hands of folks all around the world. We've seen that visualization and that power of GIS and the global capacity of how GIS can be helpful. So tonight we're going to hear about how GIS is being used to visualize climate stability models and migration of hundreds of bird species. So with that said, I'm so honored to introduce tonight's speaker. We have joining us Lotem Taylor, who has been with the Audubon Society for 6 years now. And so she leads geospatial team and analysis team for both the Migratory Bird Initiative and also the conservation science team, looking at and visualizing how bird species are moving from place to place. So I'm going to stop talking. I'm going to turn over the sharing capacities to Lotem. Lotem, thank you so much for joining us tonight. Let me stop sharing. So let's go ahead and let's give her a virtual round of applause. And again, thank you so much for speaking to the group.
Thank you so much for that warm welcome and for having me here tonight. I'm really excited to share something that I've been working on for a little over a year now at Audubon. It's about mapping conservation challenges for North America's migratory birds. And before I jump into my presentation, I just wanted to take a moment to acknowledge some of the other people that have helped out on this project. It definitely wasn't only my effort, but this was part of a larger team effort involving contributions from my colleagues, Melanie Smith, Nat Seavey, Giselle Vandrick, Erica Knight, Connor Bailey, and Jill Deppy. And none of this would have been possible without them. So I just wanted to acknowledge them right off the bat. So just to give you a little bit more background about me, I am a GIS and data analyst, as Cassie mentioned, and I have been working at Audubon for about 6 years now. I joined Audubon science team back in 2015. I actually started out at Audubon as an intern, just doing a lot of data entry stuff. But luckily I was able to move into more interesting work and now lead analyses and do a lot of GIS work. So that has been a lot of fun. Before starting at Audubon, I have some prior experience working on wildlife research and conservation projects. And that's really where I got more interested in doing GIS and mapping. My role on those projects was more field-based and also doing more data entry, but that's really where my love for mapping was ignited. Before that, I got my bachelor's degree in conservation and resource studies from UC Berkeley. And I knew from a young age that I wanted to get into conservation. I always really loved nature and wildlife. I grew up in a rural area in Northern California, and now I'm based in Southern California. I saw someone else was joining from San Diego tonight. That's where I am too. And yeah, my identity and my background is really based in the Western US, but now I have the opportunity at Audubon to map places far beyond my own backyard and the places that I'm familiar with. Birds are moving around all the time, so it really is a broad area where we're mapping. So this is just a little map I put together of some of my past projects and where those were located. And then, yeah, moving on into this project, this one is more hemispheric, as I mentioned, and that's because birds are constantly moving around. So in the US and Canada, we have about 550 bird species that regularly breed here, but migrate elsewhere. I think there's at least one species from the US and Canada that migrates to each of the 7 continents, but most of them move between North and South America. So that was really the extent that we focused on for this project here. And these migratory birds might spend up to 3/4 of the year outside of the US and Canada. So it's really important to understand where they are when they're not here and to consider that part of their life cycle as well. Migratory birds have also been in decline. We've lost about 2.5 billion migratory birds since 1970. And that's really an astounding number and really a motivating number for why we need to map conservation challenges to these species so that we can better aid in their conservation. So that's really the background for this project here. Our objective was to map migratory birds' exposure to conservation challenges over the year and throughout the hemisphere, and to understand where and when they're most vulnerable so that we can target conservation efforts appropriately. And during this presentation, you might hear me kind of switching between saying conservation challenges and threats. Those are kind of synonymous with each other, but conservation challenges is the language that we've adopted here to really make it more about the conservation solutions that apply to those. So getting into this project, this is a really big scope. There are so many migratory birds, there are so many conservation challenges that they might face, and they really have these very broad distributions that are constantly changing over the year. So we had a lot of considerations getting into this, that we had to keep in mind. The first was in our selection of conservation challenges. We can't map everything, and even if we wanted to, not everything is available to be mapped. So we had to think about how we wanted to select which conservation challenges to include. And then for those that we were able to map, we had to think about how we accurately and clearly represent those challenges across the hemisphere. When you're working at such a large extent, it's really hard to stay accurate because the data quality just might not be that good everywhere. And then finally, in terms of framing, we wanted to think through what the implications of these maps would be for both birds and people. So we didn't want to come at this from a more doomsayer perspective, but wanted to think more proactively about how we could find conservation solutions that work for both birds and people. So this map that you're seeing on these slides is an example of what we had in mind when we started this project. It's a map of blackpoll warblers and light pollution. And you can see their distribution changing over the year here. Their population size is shown as different marker sizes. So where there are larger markers, that indicates that there are more birds. And where there are darker colors here, that indicates more of this particular conservation challenge. So in this case, we're mapping light pollution, which is really important during migration because lights can disorient birds as they move and attract birds to buildings, which then might lead to building collisions. So here we're seeing that they are most exposed to this challenge during their migration. And that's where they're really going to have the highest impact from this challenge. So we wanted to come up with a process where we could extend this kind of mapping approach to all the species that we cared about and to all the conservation challenges that we were able to map. So we came up with a general approach for how we wanted to do this. And this is just in a nutshell what our process was, and I'll go into each of these steps in a little bit more detail. But first, we wanted to develop a list of priority conservation challenges to map, and then map the distribution of each of those challenges. We wanted to evaluate species sensitivity to each of those challenges so that we were accurately pairing together species with challenges. And then once we had all those inputs, we would map species exposure to each conservation challenge that they were sensitive to across the hemisphere and throughout the year. And then finally, once we had those maps, we wanted to make them available to the public for education and conservation purposes. And we are currently in the process of doing that by building an interactive online public platform, which should hopefully be coming out soon. We are thinking sometime this year for the launch of that. So keep your eyes out for that coming soon. So just to get into a little bit more detail for each of these steps, that first step, developing a list of priority conservation challenges. A lot of conservation organizations are trying to document threats to species and come up with lists of what those most important threats are. So we definitely weren't starting from scratch here. Instead, we relied on the Open Standards Framework, which was developed by the Conservation Measure Partnership. And this is also a framework that's in use by the International Union for the Conservation of Nature, or IUCN. And the way that they define threats here is that they're the proximate human activities or processes that cause stresses. And this is really different from the degraded condition or symptoms that might result from those activities. So something like deforestation is a result of a threat like logging. And it's really helpful to frame threats in this way because then it becomes more about the behaviors that are responsible for the problems, and we can work on solutions addressing those behaviors. So another important piece of this is that those conservation challenges are organized in a hierarchical approach. So there's different levels of detail that we could map. At the broadest level, there are 11 level 1 conservation challenges. At the next level of detail, there were 43 level 2 conservation challenges. And at the most detailed level, there's 84 level 3 conservation challenges. And we really wanted to get at the highest level of detail available. So most of the time we were looking for data sets that would support this kind of level 3 mapping, although in some cases that wasn't always possible and we had to move up to level 2, but that's really what our goal was. And then thinking about that list of 84 conservation challenges, that's quite a lot, and not all of those could be mapped. So we thought about how we wanted to prioritize which ones to include for this project. And to do that, we thought about a couple other concepts from the Open Standards Framework for mapping threats. So the first thing was exposure, or the spatial overlap between a threat and a species. And we really wanted to make sure that the threat was mappable in order to include it in this project. And unfortunately, a lot of conservation challenges dropped out here just because data weren't available to map them. And then next, we also thought about the sensitivity that a species had to a conservation challenge. So we only wanted to include those challenges that actually had evidence of harming migratory birds. And then finally, we thought about irreversibility, or the level of permanence of the conservation challenge, and thinking about whether or not there's actually something that we can do about it from the conservation perspective, because it wouldn't really be that useful to map things that don't really have anything we can do. So we started with those 84 level 3 conservation challenges. And after this filtering process, we ended up with just 19 that we wanted to map. So next up was mapping the distribution of each of these challenges. And even though I'm presenting this linearly, a lot of these processes fed back into each other. So it wasn't as straightforward as I'm making it seem, but this was kind of the next step in our workflow. So to do that, we first identified potential data sets that we could use to represent the distribution of each of these conservation challenges. And then for each of those data sets, we also had to think about what an appropriate threshold would be for defining what areas were included and what areas were excluded. And then once we had those two pieces, we were able to create maps. And we shared those with a wider group of people beyond the project team, people that were familiar with these conservation challenges and the areas that they might affect, so that we could get a better sense of how accurate these maps were of the conservation challenge based on those expert opinions. So once we went through that process, we ended up with those 19 maps of the conservation challenges. They span different categories from the Open Standards Framework. Those included residential and commercial development, agriculture and aquaculture, energy production and mining, transportation and service, biological resource use, human intrusions, natural system modifications, pollution, and climate change. And you can see this GIF here cycling through the different layers that we ended up using for these conservation challenges, and then the data sources that were involved. So the next part of this process was a pretty meaty effort on its own, but we needed to evaluate species sensitivity to each conservation challenge so that we could accurately put together maps of species abundance and maps of the conservation challenge distribution. And this was a really huge effort, so we actually partnered with some external people as well to take this on. And we did this for all of the migratory birds, and not only those 19 conservation challenges that we ended up mapping, but actually that full list of 84 level 3 conservation challenges. So this was a really huge table at the end of that. And not only did we include each of those pairs, but for every species and conservation challenge pair, we evaluated whether there was evidence that it caused stress based on 6 criteria. And those were direct mortality, loss of habitat quantity, loss of habitat quality, effects on prey or forage species, effects on reproduction, and then effects on nesting. So this was a really, really huge effort. And we scored whether or not it caused stress based on the literature review as either 1, that it caused stress, or 0, that it didn't cause stress. And if there was some mixed evidence in the literature, then we gave it a score of 0.5 so that we could go back and assess those later based on expert opinion or how lenient we wanted to be with this mapping effort. So once we had all those inputs, we were able to get to the fun stuff for me, which was mapping the species exposure to each conservation challenge. And I've already kind of walked through what we used for the conservation challenge layers. But for species abundance, we were really lucky to have a very rich data set that Cornell has produced called the eBird status and trends models. And those are maps of species relative abundance that are created hemispherically. They have them for hundreds of species. And not only that, but for every week of the year. So you can see how those species abundance change over time within the course of a year. And we decided to pair these together with the conservation challenges to create these bivariate maps. So the two variables that we were interested in were species abundance, looking at where there are more birds, and then conservation challenge exposure. So where are more of those birds more exposed to the conservation challenge? And we chose to represent species abundance with size, like you saw in that first example map, and then conservation challenge exposure by color. And for each of these, we used 5 class breaks, and I'll get into a little bit more detail about how we defined those. So for species abundance, we used an isopleth method. And basically what that approach does is it takes the total value of all of the cells in a data set, and it splits them out into equal value classes. So here in this map, for example, you see 4 cells here along the Gulf of Mexico, and that's where the top 20% of the species is found in this week. And that equates to the same number of birds as are in all of these lowest class areas with the smallest markers over here and here. So this is looking at the species in terms of where it's the most dense. And this is really well suited to mapping wildlife distributions because you often do get these high concentrations of a species in a given area. So this is a map of scissor-tailed flycatcher in just 1 week of their fall migration. And then for that same point in time and that same species, we also looked at how exposed they were to a conservation challenge. So here we're looking at suburban development, and at the highest level, we're looking at places where 71 to 100% of the population is exposed to that conservation challenge. At the next level, 31 to 70% of the population is exposed. And then at the next level, 11 to 30% of the population is exposed. And then at the lowest level, 1 to 10% of the population is exposed. And then we also include these areas in gray where there's not conservation challenge present, but the species is still present because we didn't want those areas to be dropped out of the maps. So putting these two things together is what creates those bivariate maps. So you can see from the abundance map that there's a really high concentration of birds around the Gulf of Mexico. You can see in the conservation challenge exposure map that there's a high degree of conservation challenge exposure in Southern Central America. And when you put those two things together, it really changes the picture. So even though conservation challenge exposure is high in Southern Central America, what really stands out is that area in the Gulf of Mexico, where you're seeing the top 20% of the birds are also at pretty high exposure to this conservation challenge. So this is just one species, one conservation challenge in 1 week of the year, but we developed a workflow so that we could apply this to all the species of interest for all the conservation challenges and for every week of the year. So this was a pretty big process to run. It started out with thresholding those conservation challenge layers to delineate their footprint, and then aligning those conservation challenge layers to the species abundance layers. And once we had those data sets all lined up, we could easily identify where the conservation challenge and the species distribution overlapped with some simple raster math. And then once we had those rasters, we summarized them into hexagon grids. And we did this because the data are not super fine scale, even though we process them at a 3-kilometer scale. It's really more appropriate to look at them at a more regional or landscape scale. So we had 2 summary grids that we used for this. One was 50-kilometer hexagons, and then the other was 150-kilometer hexagons, so that people could get a more localized view and a more hemispheric view of the data. So within each of those hexagons, we summarized total species abundance and then proportion of the population that was exposed. And as I mentioned, we ran this for every species, week, and conservation challenge at those 2 summary scales, and that amounted to nearly 1 million summaries. And then once we had all of those summaries, we worked on publishing them to ArcGIS Online and creating filtered views of the data based on the species and conservation challenge pairings that I discussed in the previous step. And then finally, once we had those maps, we worked on surfacing them in an interactive online public platform. And this is just a prototype to give you an idea of what is to come with our Bird Migration Explorer. But here you can see those same maps of scissor-tailed flycatcher and suburban development. And here you have the map of the species distribution changing over time. You have a time slider where you can pause or play that. And in the bottom here is a histogram showing how the total population of the species, not in these localized areas, but as a whole, is exposed to this conservation challenge. And in this viewer, you also have the option to explore different conservation challenges that you might be interested in, or explore different species, or if you want to zoom into a particular area, this is just a screenshot showing it at one scale, but it's possible to dive deeper and get that localized view that I was talking about. So that's all I have to share with you today, but keep an eye out for that Bird Migration Explorer. It should be coming out soon. In the meantime, if you want to learn more about our work, you can check us out at audubon.org/migration. If you have any questions for me that I don't get a chance to answer today, you can email me at lotem.taylor@audubon.org. And then finally, I just wanted to put in a plug to get involved and join Audubon if you're interested in birds or GIS or conservation. We have a lot of career opportunities listed on our website. And in particular, I just wanted to put in a plug for the Dangerman Fellowship, which is a year-long GIS fellowship at Audubon that just started accepting applications this week. So if you're a GIS student looking for a job this summer, that could be a good opportunity for you. Yeah, and that's all I have. So thank you again for having me here tonight. And I think we'll turn it over to Q&A from here.
Oh my goodness. Thank you so much, guys. Let's go ahead and give a virtual round of applause. That was amazing. And I have a little tear in my eye here from the visualization standpoint. It's just beautiful. Thank you so much.
Thank you so much.
And talk about big data and processing that big data. It's a heavy lifting to be able to do that. And for many of the students that are in the program, they have to do a capstone thesis. And the way that you broke down the methodology and step-by-step was just brilliant. So I'm so glad so many students are seeing your workflow and how you're describing it. So just thank you.
Thank you so much.
So we did have a question that came in. This was from Ian. And he said, do you mind talking a little bit about how you went about evaluating the quality and accuracy of each of the data sources that you mentioned here?
Yeah, that's a really great question and was definitely no small feat. I think each one of these steps could be a whole presentation on its own. But some of the things that we looked for when we were evaluating those data sets were how recent it was. We didn't want to put up challenges there that were from several decades ago, even if that was like the latest data that was available. We just kind of chose not to map things in that case. And then another thing we looked for was high resolution data. A lot of these are based on satellite imagery. So luckily that wasn't too much of a problem, but then some of the other data sets were based on more broad scale analyses of human influence on the landscape. And in those cases, those are kind of dodgy, I'd say, like that. And that's kind of why we ended up with the upscaling approach at the end and summarizing things by those hexagon grids, just so that we were a little more true to the scale that would be appropriate for those data sets. So those are some of the main criteria that we kept in mind for evaluating the accuracy of the data. And then, as I mentioned, we also had an extensive review process of all the layers that we came up with. And that was mostly an internal review from people throughout the Audubon network who are working on these various conservation challenges and work in different regions. So they could say like, this doesn't really look right in my area or not. And me having just a very California-centric background, sometimes it's hard to say whether a data set is accurate if it's mapping a place you've never really been to or don't really have as much on the ground expertise with. So that was a really valuable resource for us.
Excellent, thank you. So more questions are coming in. Leslie would like to know what bird species is your favorite and which one is at the greatest risk according to your models that you guys created?
Yeah, that's a really good question. I would love to say it's like Anna's hummingbird, the bird right behind me, that's my favorite, but I actually really love California towhees. They're a bird that has kind of like stuck with me in my life. Everywhere I've lived, I always see them. So I guess we have similar habitat needs. But yeah, that's probably the bird that feels the most like home to me. So it's one of my favorites for that reason. In terms of which birds are most at risk based on our maps, I think that there's a lot of ideas that come to mind, but we haven't really done a very systematic analysis to find which species is the most at risk. We're really thinking about this as an effort to evaluate each of these conservation challenges in each species one by one. But because this isn't a super comprehensive look, we were only able to map 19 of those 84 conservation challenges. It's really hard to say which bird is the most at risk overall. So that's definitely something that we could look at in the future with more time and more resources available, but it's not something that we've really evaluated yet.
Great. So a question that Mark has for you is, in comparing Northern Hemisphere and Southern Hemisphere, sometimes you have discrepancies with how data is collected.
Totally.
Did you find any areas where there was this discrepancy and lack of data, and how were you able to mitigate that?
Yeah, that's a really good question. And for that reason, we really often had to just go with global data sets where everything was kind of put together in the same systematic way. I will say that the one exception we made to that was in our maps of sea level rise, where there's really great data available for North America that NOAA has put together. They have these really impressive maps of marsh migration under sea level rise. And we really wanted to make use of that resource. But then globally, we were kind of stuck with a lower quality data set, but we didn't want to exclude those areas. So we ended up combining those two data sets, a high quality US data and then a global data set that looked at sea level rise everywhere, and just taking kind of like an equivalent scenario of sea level rise from each of those data sets and merging the two together. So that was one of the ways that we handled having different data quality, but we really didn't want to leave any gaps on the map. So we didn't want to map something only in North America if we didn't have something that we could put on the map for South America, because that would really bias our maps towards showing greater need for conservation in North America when we know that that isn't necessarily the case.
Okay, excellent. A student had a question about NASA. They see that NASA was mentioned as thank you for helping at the end, and how were they able to help? Was that with the sea level rise or?
Yeah, that's a good question. So NASA was one of the main data providers for the conservation challenge layers. Since, as I mentioned, a lot of it was based on satellite imagery, we were able to make use of a lot of the data sets that they've put together. And they've organized a lot of data sets online and just made it very easy to find layers for various things. So you'll see in some of the slides that I put their logo, and that's because we got data from them for that conservation challenge in particular.
Oh, excellent. Yeah, a wonderful resource. So we're getting into the, look under the hood here. Students are wanting to know what software were you using for mapping purposes? And then also from the workflow standpoint, could your workflow be, insert any type of animal that you're looking at to be plugged into your methodology and workflow? Would that be something that could work?
Yeah, sorry. So the first question was about software. There was one slide in there. I didn't really call too much attention to it, but with the workflow, I kind of put a logo for each of the software programs that was used along the way. But primarily we relied on Esri's ArcGIS products for mapping and making sure everything looked right, and also for ultimately delivering those data online. And then for a lot of the data processing that involved more data manipulation, we used R for that instead, just because it's a little more friendly for doing those kind of large-scale data manipulation exercises. So I'd say between ArcGIS and R, we pretty much had it covered. And then there were some other parts of the process that made more use of things like Excel, like to develop that species and conservation challenge spreadsheet, linking those all together.
And then the second part of that question was, could any species be put into the model and right. work in your workflow?
Yeah, I think that that's a really good question. And luckily for this project, we were able to build on past efforts from other researchers, and Cornell in particular. Their models of bird distributions over the year were essential for this effort. So I would say that it is possible to apply this to other species, but not all species have that same level of data and modeling that has already gone into them that we could build off of. So definitely possible, but it's not always available.
Mm-hmm. Excellent, thank you. David has a great question for you, and he wants to know, in your opinion, based on what you've seen, this is your project and you've been working on it for so long, what are the top one or two behaviors of humans that could change, like from light pollution or on a day-to-day basis that could perhaps, decrease the impact of these migratory birds?
That's a really good question and a really hard question. I feel like because of the data constraints for this project, we also aren't really able to evaluate threats to each other super well. We can kind of look at them one at a time, like I was saying, but when it comes to cross conservation challenge comparison, there's a lot of room to improve those and make sure that they're directly comparable to each other. In terms of human behaviors, though, I feel like what really stands out to me is just how much we've already modified the landscape. And so minimizing those areas, it seems like a great way for us to minimize our impact overall. So many of our conservation challenges relate to modification of the landscape at really large scales, like through urban and suburban development, through agriculture, modifying coastal processes, modifying water processes. It's really impressive to see our scope and kind of disturbing to see how much of the Americas we've already changed. So yeah, just personal opinion, it seems like minimizing those kind of modifications to natural systems would be best. But yeah, it's hard to make direct apples to apples comparison based on our results.
So this is the part where, you're coming to an end, right, of this project, and you're starting to create an interactive visualization, which I know I am so excited to see. So when that becomes available, I'll be able to share it to our LinkedIn page and share it with the students. But oftentimes, you have reflections about what could have been done differently, or you're thinking back going, oh gosh, that was a very cumbersome process there. Is there anything when you're thinking about data processing, map creations that you would have done differently? And this is a question that Ian has posed. So it's a wonderful question for reflection.
Yeah, totally. And I will say that there have been some false endings already for this project where we thought we had wrapped up, but we realized we had to go back and revisit something that we had worked on because it just didn't seem right to people. So I think there have been opportunities along the way for us to revisit some of that past work and make some of those changes. But something that comes to mind is like just having that built-in time for review, because there are so many inputs to this process, and we really had to start from a place of little knowledge going into it, like whether it was figuring out which conservation challenges matter the most to birds, or what data are available to map those, or how they actually link up to species and what species are impacted by these challenges. There was a lot of information to compile, and not all of that can be done by just a small group of people. So I think throughout this process, we were able to go back and kind of modify some of those steps and include a broader group of people who are experts in those areas. And then also give it more time for review by other people who work in those areas. And that's something that I feel lucky to have been able to do on this project. It's not always an option I've had on other projects to have that broad expertise to draw from. So I'd say going forward, that's something that I hope we can continue to do on this project and keep revisiting things as necessary. And one of the great things about having these results published to an online viewer is that I think we can go back and more easily make changes than if the end product of this was like a peer-reviewed publication, where it's a lot more complicated, I think, to then go back and change your results. And I think there's more of a stigma attached to that than with like an online viewer where you can go back in and update things. So it's really nice to have the option for that, because I'm sure things will continue to change the more people look at this and review our work.
Excellent. I have a question for you about just the helpfulness of citizen science apps. Yeah. What's the Audubon's take on that? Is it helpful? Do you find it a baseline for looking at trends? What are your thoughts on that data source?
Yeah, I think it's a super important data source, and I'm kind of honored that Audubon has taken a lead on using those data. We have a lot of community science programs that go back really far in time, where those data are being used now to model climate change impacts on birds in the future, and also look at historical change. And I think that there was also some stigma with those data sets in the past because they're not collected by experts. But there are so many great birders out there that are observing birds all the time. And I think that it creates a really rich data set. And we have methods now where we can adjust for the different levels of observation that have gone into those apps and data sets, so we can make the most out of those data sets. And I think that they're a really valuable resource historically and going forward to monitor how birds are doing. So really valuable. And those are also the same kind of data that Cornell used for their models of species distribution. And it's really amazing to be able to see how rich that data set is when you look at those models and how much of the world that they cover and how rich they are temporally as well, that they're able to model each week of a species distribution separately. Yeah, it really makes you realize how much data there are out there about birds.
Oh, it's fascinating. There's been a couple of questions about the jobs and internships, and I'm going to go ahead and for everyone, I'm just going to paste in the chat window. We have a Hopkins LinkedIn page where I'm always posting jobs. So I have posted the fellowship there. So please, folks that are on here, please check it out. Hopkins students, this is for you. Please apply for these fellowships. They're just so exciting, and we get to hear firsthand from the folks that are a part of the organization. Okay, so one other question that came in, and I think this might be our last one, unless anyone would like to raise their hand and ask their own question. However, I'm more than happy to do so for you. So you did mention public data sources. Do you have links or references for that folks and students can use on their own projects? Like, do you have a go-to site? And we all, from GIS standpoint, we love data resource and collecting those resources. Yeah. Is there one like go-to that you feel like, oh yeah, this is where I go to get majority of the data?
I think that's a really good question as well. Throughout this process, having a large team to work on this was really helpful because everyone kind of had their own go-to websites for where to find data sets. I like to look at like a lot of the government sources of satellite imagery and derived products from those. But other data sources that have kind of recently come across or have been useful for this project, the CDAC, I can't remember exactly what it stands for. I think it's Socioeconomic Data Application Center. They have a lot of really great global data sets that we made use of for this project. There's things like Databasin, which also are huge GIS data repositories. And then things like ArcGIS Online, where you can search for publicly available data sets that way. So all of those are some of the resources that just come to mind initially as ones that we made use of for this project. And then if you're interested in birds specifically, places like Cornell have a lot of data available on birds. And there are just so many rich data sets out there. So I'm sure I'm blanking on some that were really important for this, but those are some of the ones that come to mind. And if there are any like specific questions about a data set that I shared today and where it came from, I'm more than happy to follow up and point you to those specific resources.
Excellent. And it's so nice that these data sets are available and that we don't have to walk around with large external hard drives or where we're storing these data sets ourselves, that they are readily available. So that's one thing that has just been so fabulous over time with geospatial data.
Definitely. And it's definitely helped to make all this possible, and mapping migratory birds would not be possible without the rich data sets that have been collected already.
Excellent. Well, so are there any other questions out there? I'll say a couple things, kind of like doing some chores here and doing some announcements for the program. For folks that are not part of the program and are interested in classes that we offer in our flexible online program, I'm going to go ahead and put a link in our window here, and feel free to check out the program as a whole and the wonderful electives that we offer. For current students that are interested in electives, we have launched our second environmental science eDNA drone collection course that's going to happen this summer. So basically using all different types of drones, subs, aerial drones to collect eDNA. So that's the second link that I'm going to post in the window here. And with that said, I just want to thank Lotem so much for being here today and just really walking us through her complex project and sharing the beautiful visualization. It's so beautiful to see, and knowing that it takes a team, and that, you know, crunching of that data and being able to have that beautiful map is a long process, but it's an important story to tell. And, you know, these birds they're counting on you to tell that story. And that, you know, that's just a wonderful hat to wear. And just thank you so much for being with us today. So let's give her a round of applause in the chat window.
Yeah, thank you so much for having me. And to everyone who tuned in, I really appreciate everyone's interest in this project. It's really exciting to share it with you guys.
Excellent. So before we leave tonight, I just want to remind everyone that March 3rd is going to be our next time that we're going to meet. And I'm going to go ahead and put the Eventbrite ticket in the chat window. You can get your ticket now. And we will be hearing from Caroline Rose, who will be joining us from the Wisconsin Geological and Natural History Survey group. And she's going to be talking about all the wonderful things that she's doing with GIS. So again, Lotem, thank you so much for being here tonight. And folks, thank you for joining in on this beautiful Thursday evening. And I wish you all well and have a happy and productive week and weekend. Thank you, guys.